Alright, today's a new one. We're going to look into chapter 8, vectors. Alright, so vectors. We're going to be looking into three things. The first one being a little introduction, where we're going to be looking into three things, being the direction, when we're referring to vectors, and then the magnitude, and also collinear. So we're going to see how these three things work in vectors. And then we're also going to be looking into the addition and subtraction of vectors, where we're going to see some laws, mainly the triangle law, the parallelogram law, and finally the polygon law. They're mostly the same when you go through them, all similar concepts. We just have to understand them. And the last thing we're going to be looking into is vectors in a Cartesian plane, where we'll be looking into three more things. Firstly being non-parallel and non-zero vectors. Alright, non-parallel and non-zero vectors. And then we're going to be looking into position vectors. And finally, unit vectors. Alright, so those are the three little subtopics in each subtopic for a vector that we're going to be looking into for today. Alright, so the introduction for vectors. First thing first, we're going to look into the direction. So basically, let's imagine you have two lines. Alright, let's imagine that they're the same thing. So this is A and B, this is A and B. So the way vectors works is basically it's like getting from one point to another and letting the movement to that one point be an unknown. So let's say the vector from point A to point B, we can actually say it as AB with an arrow on top. Alright, but if we wanted to say the vector from B to A instead, that means the other way, it would be vector BA. So get it? It's like going from B to A. AB from A to B. But the thing is, vector AB can be equal to vector BA, alright? If it was negative. So that means the vector of negative AB is equal to BA, alright? This is a very important one, because sometimes you might have to you work with vectors which go the opposite direction. Alright, next thing is we're going to look into the magnitude. So let's imagine we have this vector. Alright, this vector is, they basically call it R. So what is the magnitude of R? So usually we state the magnitude of R by using the modular sign. So let's say that R is been given that right down here is 3 units, and the other direction here is 4 units. So basically the way we find magnitude is like the same thing we find distance. So we basically use the same units over there. So it's square root 4 square plus 3 square 16 plus 9, 25, root 25 is 5. So the magnitude of R, vector R, is 5 units. We're usually going to use this a lot because sometimes you might be given, let's say, like the magnitude of A, and then you're given the magnitude of B, but then they ask you to find the magnitude of C. So it's like basically simple triangle laws like that. And the last thing is we're going to be looking at is collinear. So basically, when we say collinear, it's basically saying that certain points are on the same line, alright? So let's call this P, Q, and R. Basically, they'll usually you would have to find it in the equation, or it's already given. But the way you prove P, Q, and R are collinear are first by choosing two vectors, sorry. So what I usually choose is P to Q and also P to R. So in this case, it's given that PQ is equal to 10a, whereas PR is equal to 4a. So let's say that you already have these two vectors, right? The way you prove PQ and R is collinear by proving that they are parallel and they share the same common point. So usually we answer this by giving a statement and I'll show that. But the working for this is basically by letting, so we let PQ equals to KPR because we want to prove that it is parallel, right? So then we just sub in the value. So 10A equals to 4KA, right? That would mean that K would equal to 5/2. Now, the fact that we found K, basically PQ, basically from here we can prove that PQ equals to 5/2 PR. That means that PQ and PR are the same thing. It's just that PQ is longer than PR. Alright, so just by proving this ratio, you can already state that PQ is actually parallel to PR. Alright? And the final piece of working that you need to include to finish up your answer is by writing therefore P, Q, and R, basically point P, Q, and R is collinear because vector PQ and vector PR are parallel with P. Are parallel with P as a common point. So basically the keywords that you want to have here are parallel and then P as a common point. So these two keywords have to be in your answer for you to get the marks when answering proving collinear dots, basically. Alright, so now we're going to be looking into addition and subtraction of vectors. So first one, triangle law. So basically we have to show this. The way I'm going to show you guys how this law works is by drawing a triangle. Alright, let's say A, B, and C. So basically it's given that vector AB is U and vector BC is V. So what is vector AC? So basically the triangle law is that vector AC is actually equal to vector AB plus vector BC. Okay, that means going from A to C is the same thing, alright, as going from A to B then B to C. So that's how vectors works usually. Like it's like adding, but you'll still end up at the same spot basically. So in this case, vector AC would equal to vector U plus vector V. Alright? Alright, so the next law we're going to be looking at is the parallelogram law. Okay, so let's draw our parallelogram here. Okay, one of them. Alright, I know they're not particularly parallel to each other, but this should work. Alright, so okay, as long as you see these lines, these arrows, you already know that they're parallel, right? Usually they're stated in the question. So let's say A, B, C, and D, right? Alright, so the way the parallelogram law works is that, okay, let's say that AC here meets, right? Okay, so basically, let's say AB is vector U and AD is vector V. Okay, what is vector AC? Alright, so vector AC, if you think about it, is the same thing as AD. Alright, since we learned the triangle law just now, right? AC is equal to AD plus DC, right? Or it could even be equal to AB plus DC. Okay, So basically, both of these apply actually. So I'm just going to choose one of them. Let's say AD and DC, right? So AC equals to AD, vector AD, plus vector DC. But the thing is, we don't know what vector DC is. Now this is where the parallelogram law comes in. Basically, since DC and AB are parallel because they're parallelograms, right? It's one of the laws. In a parallelogram, basically opposite sides are parallel to each other, and opposite sides are the same length. So from there, we know that vector AB equals to vector DC, alright? Let me write that down. Vector AB equals to vector DC. And also, vector AD equals to vector BC. So basically, it doesn't matter which one you choose. So basically, I could just say AC also equals to vector AD plus vector AB because we already know the parallelogram law. You don't actually have to state this during exams, but just knowing it will make your working easier. So we already know that vector AC will be equal to vector U plus vector V, alright? Now the last one is the polygon law, alright? So let me draw a little pentagon, okay? Very quick one. Alright, so let's name it points A, B, C, D, and O. Okay, so let's say all these are vectors. Okay, so let's say we wanted to find vector OD, right? Alright, OD, alright, that way. Okay, vector OD. Okay, finding vector OD is the same thing as OA plus AB plus BC and plus CD, alright? Just to get this lucky guy over here. It's the same thing as adding all four. So no matter what weird shapes you get during a question, just remember, if they end up at that same point, you will get the answer, alright? No matter if it looks like it's so many adding to just get this short line, they will actually like balance and check over there. So we can actually write out that OD equals to OA plus AB plus BC plus CD, alright? You get it? It's like hopping. So it's O to A, then A, B, B to C, C and ends at D. So it's the same thing as O going all the way to D. Alright? So that's just the method of answering, usually for vectors. Alright, now lastly, we're going to be looking into vectors in a Cartesian plane. Alright, so usually vectors in a Cartesian plane, we won't be given like a specific vector. It won't be like X or Y or A and B. Usually it'll be written as I and J, okay? So I being movement on the x-axis, or basically horizontal movement, and J being movement on the y-axis or vertical shifts. Basically, you can rewrite it as, let's say, value of x and then vector I plus value of y, vector j, is the same thing as column vector x, y. So column vector is basically like a vector, but you don't even have to have all the plus signs and all. So let's say if it was like minus yj, it was, instead of going up, it's going down, you just have to add negative y over there, right? But basically, one of the things we need to know, keep in mind, by the way, x is always above of y, okay? X is always above. But the other thing we need to know is non-parallel and non-zero vectors. Alright, so this one's a very special case. Non-parallel, non-zero vectors. So basically, the thing that questions will do is usually they'll give an expression. Well, not an expression, sorry, an equation. So the example I'll give right now is 2 vector x plus a vector y. This is not necessarily in vectors in a Cartesian plane, but it could come out. So not necessarily it will be in I or j, it could be in x and y like I'm doing right now. So let's say they give you 2x plus ay equals bx plus 4y, right? And then they tell you that x and y, alright, so they tell you that vector x and vector y are non-parallel, alright, and non-zero vectors. That means that the coefficient of x and y equal to 0. Alright, I'll do this, I'll show you through my working what I mean, alright? So basically what you want to do is, you want to make it to where there is only one x, there's only one y. Because as you can see right now, there is 2 of everything, right? Let's make only 1. So let's bring everything to one side. So I know that 2 minus b, bracket vector x, will equal to 4 minus a of vector y. So basically, from here, we know that non-parallel and non-zero vectors, the coefficient of vector x and vector y equal to 0. That means, from here, we can say that 2 minus b equals to 0. That means b equals to 2. And also 4 minus a equals to 0, a equals to 4. And you've already found the answer. That's how non-parallel and non-zero vectors work. Alright, next up, position vectors. So basically, position vectors are something like this. So let's say you've been given a little graph, right? So imagine this is like the most uniform Cartesian plane you've ever seen right now, okay? So let's say that they gave you point P, they give you point Q, right? And they give you like PQ over here. Okay. So position vectors means that it's like the vector from the origin to the point. Okay? So that means the position vector of P is actually some value of x here and some value of y over here. Okay? But remember, it's going to be like yj and xi. Okay? So basically, OP, alright, position vector OP is equal to xi plus yj. Okay, it could be minus, it could be negative or anything. Or easily, you can just write the column vector xy. Alright, a very easy way to find position vectors is by just putting in the coordinates. Basically, we know that x and y is the position vector, right? It's also its coordinates. So let's say you've been given point P as 2, 3. That means the column vector would also be 2, 3, or 2i plus 3j, things like that. And easily, if you wanted to find the magnitude of this position vector, is the same thing as using the formula, the formula of distance on the x and y value, right? Just like that. So that's how position vectors work. You usually have to keep position vectors in mind when you want to prove collinear, because usually they will give you like position vector of P, position vector of cube, and position vector of R. Alright, and then they give you O. Alright, so they will give you like they'll give you OP, OQ, and OR, but they want you to prove PQ and R are all collinear. So basically what you do is you have to find PQ and PR, or PQ and QR. So basically you have to do that by doing like PO plus OQ, then PO plus OR. So you find PQ and PR, then just do the whole formula we did just now, the working I did initially. And finally, unit vectors. This one's a very, very straightforward one. Basically, we write unit vectors by writing the vector and then a little like arrow at the top. You can also rewrite it as the vector of A over the magnitude of vector A, which is equal to xi, so let's say that the x and the y have a value, right, over the distance, right, the magnitude formula, x squared plus y squared. So I could rewrite this as 1 over root x squared plus y squared, and outside xi plus yj. So usually what people do is they will find the x and y below here, and then they will expand it into x and y here. So maybe like the bottom is 2, but then the top are like multiples of 4. So you could divide and be left with another vector like that. But that is our chapter on vectors. Thank you. Alright, so before I forget, let's just run through some quick tips. I think number one would be ratios. So basically, vectors is going to come with a lot of ratios. Usually like when you're trying to find parallel vectors and all. Basically, when you have to work with ratios, just like coordinate geometry, working with ratios is a bit of a hassle. You have to remember that when you divide them, you can turn them into ratios. But that's a very important thing when answering vector questions. I think number two would be about remembering like shapes, I would say. Yes, shapes is a very important thing. Do not think that they will only be giving you a parallelogram or a square. They could give you a lot, you know. I've done questions where they gave me kites, you know. They've given me a kite. So let me draw. Alright, yeah. So let's imagine that this is a kite, alright? Alright, it's a square, but in another way. They gave me kites, I've done trapeziums, and sometimes you have to remember that they're parallel on certain sides, so it really matters there. But apart from that, I think that's all you need to remember. Usually vectors in a Cartesian plane, yes. Vectors in a Cartesian plane are like an important one. Basically, you always have to look at the x and y values. Those are very important because it's like giving you the free position vectors. So you don't even have to think when you answer those kind of questions. And midpoint. Yes. So basically, let's say they give you a vector, right? They give you A and B. And let's say vector AB is equal to like 4A, right? So let's say that there's only a point C, and they see C is the midpoint. And then they ask you, what is vector AC? Basically, since we know that C is the midpoint, vector AC is half of AB, which is the same thing as 2A. Alright, so that's another one that you have to remember. Hope you guys enjoyed the video today. Look forward to the next ones. Ciao!